All right, so this example is how to find your delta given your epsilon using your calculator. So let's take a look at where this comes from again. So remember, it's that first part, take away 2, and that's what's going to be less than epsilon. So it's our function f of x, take away the limit is less than epsilon. And this is x, take away 1 is less than our delta. So if we start with what we're given so far, we already know that our function has to be within 0.2 of 2. And so this has to be less than 0.2. So we know our limit's 2, and we're going to go up to 0.2, so 2.2, and down 2.2. So up 0.2 from 2, down 0.2. And just reading it too, it says that we need to be within 0.2 of 2. So that's up 2, down 2. Now we need our function, and this is a pure calculator problem. So we're going to plug all of this in, use the limits for our y values, for our y min and y max, and use the x values for our x min and x max to get a good picture of it. And now that we know where our y values are, we're going to be able to just trace these across with our graphing calculator. So hit pause and take out your calculator. Okay, so our f of x is the x cubed minus 5x. We got to put that in. X cubed minus 5x plus 6. And then the other y values that we're going to be drawing those lines across, because remember, it's going to be some function here, and we're going to draw the lines across. So we're going to plug them in as well. So 1.8 and 2.2. So 2.2, enter. 1.8. Now this is the important part. This is making sure our window fits what we want. So we're going to go 0, and we don't have to go much more than 2.2. So how about we do 0. We don't want a scalar there. Hold on, that's a 1. We'll do a scalar 1. We put in a 0 for our y min, and our y max we go like 2.4. Let's get a little bit higher than that. And then our x min, we're going to go from 0 to, it's already got a 1.3. That looks good. We don't have to go much more than 1, because remember, our deltas are usually small, especially when we're dealing with 0.2. And then now we can hit graph, and it should give us the picture that we want. And there it is. And so you can see it keeps going here. If you hit trace and 1, it tells us exactly where we are. So that is our picture. So we're going to trace that on here. So there's 1. And then our graph comes down like that through it. And we'll do the top one in red and the bottom one in green. And so now we know where our 1 is, and if we find the red and green points, we can then find our delta. So now if you look at the calculator, you can see it keeps going. And so if we had made our window a little bit more like 3 and hit graph, you can see it comes down, goes back up, and then we're going to get 2 points of intersection, one here and one here. But if I hit trace and 1, we're over here. So that point right here, that's a massive amount of distance. We don't need that much. So if you go that far, you've got to go that far as well. So you can ignore that one. Same with this black one. If you go way over here, you're going to have to go that far over here. And we need to be within this region, remember? So we have to use that one and that one, the two that are closest to it. Okay, so you're going to go second, calc, intersect. And we'll do the red one first, the top one. So blue and red, enter. And so the red one, which is our first point down here, is 0.9114. So 0, oops, put that in red, 0.911141. I already forgot it. I got to go back. 114. Trust your instincts. It was 114. Okay, now we need to do the other one, and we'll do that one in green. So second, calc, intersect, and blue, yes. Scroll down to get the black. Enter, enter, and it should give us that point. Now with the intersections, if you were over here, you don't want to be, you want to make sure you pick the numbers that are closer here. And that's why I hit trace 1 first, and that way it'll always go to the nearest 1. All right, and so that one's 1.124. I got that, 1.124. So now remember, we do what we did before. So it's x minus 1 is less than delta. So we're just plugging it in. So 0.9114, let's put that one in red so it matches. 0.9114 minus 1, and that's going to give us a number. And then we're going to do the other one as well, 1.124 minus 1, and that'll give us a number as well. So 0.911, oops, wrong location, second quit, clear everything out, 0.9114 minus 1, 0.88.0. Okay, so that's our first number. That's our first distance here. So we know this one has a distance of 0.0886, and we want the smaller of the two, right? All right, so now 1.124 minus 1 is really bigger. So 0.1240, so 0.124. And so obviously our delta here is 0.0886. And again, it's because this right here is 0.124. And so if we went that same distance this way, we would go over here. It would be up here, and we'd be too far over. See? And so this one coming over this direction, we're a little bit under, but we're fine. But that one would give us way too far. We'd be up and over where we're supposed to be. So always make sure you pick the one that keeps you within those regions, both left and right of our delta. Remember, that's what that means. It's saying our x's have a distance from 1 that is less than delta. So our x's need to have a distance from 1 that is less than the smaller 2 that keep us within that region. All right, so the next one's yours to try. I've got it all set up for you. You just have to fill everything in and try to find out what the delta is. So how far from 1, because that's what our x is approaching, should we choose our x? Hit pause now and give it a shot. So you should have an epsilon of 0.01. We should have x cubed plus 5, limits 6. So x cubed plus 5 minus 6, in other words, that one minus that one is less than our epsilon. And then x minus 1 is less than our delta. Our a here is 1 that we're approaching. And so we take our 6 and we add 0.1 and we subtract 0.1. And then we know 6 is at 1. And so now we just have to work backwards. So plugging 6.01 into x cubed plus 5 and x cubed plus 5, we solve them and we get these two. It also verifies in the calculator of where it is. You can see it's pretty much a line here because it's such a small epsilon. So they both came out the same, which means your delta is very easy to find. It's 0.0033. So if you got that, you're good.